All right, so day 6, solving word problems using ln, the natural log. Remember, the natural log is basically like log with a base of e. So if we remember things that were compounded continuously, we had the formula a equals pert, where your new amount equals the original amount times e to the rate as a decimal times time, e to the rt. So number 1, Judith puts $5,000 into an investment account with interest compounded continuously. Remember, as soon as we see this, we're thinking pert. So, which approximate annual rate is needed for the account to grow $9,000 to $9,110 after 30 years? So I set up this equation here, pert, and we're solving for r. So keep in mind, if you were to do this in a calculator, it would give you that answer very quickly. However, we're going to solve it algebraically. So variable as an exponent, isolate, and switch to log, or in this case, switch to ln. So we divide by 5,000, right? And we get, I need to pull my calculator up, give me a second. Sorry, we get 9110 divided by 5,000, 1.822. So 1.822 equals e to the 30r. Now, what do we got here? We got a base, we got an exponent, we got an answer. So it's log bay, or in this case, ln bay, I guess. ln bay, which is ln natural log e. Remember, we don't have to put this. I'm going to put it, but we don't have to. Answer is 1.822 equals 30r. So I'm going to take this side divided by 30, take this whole answer, divide by 30. So I'm going to do that over here now. Natural log of 1.822, and take that answer and divide by 30. And there you go. We get 0.0199. Which one is that? 0.0199 is the rate. Now we got to be careful, actually. The rate is 0.0199. What is that as a percent? 1.99%, which is 2%. Number 2, determine to the nearest tenth of a year how long it would take how long it would take an investment to double at a 3.34% interest rate compounded continuously. So let's just make up any original amount. Let's say the original is 100, then we're looking for it to double to 200. So 200 equals 100, e to the rate is 3.75%, so 3.75%. So what is that? That's 0.0375. So I'm going to raise this to the 0.0375 t. We're going to solve this again for t. So let's see. Divide this side by 100, divide this side by 100. We get 2 equals e to the 0.0375 t, which gives me, let's see, got a base, exponent, answer. So ln base e, remember we don't have to put that, but ln base e of 2 equals 0.0375 t. Divide by 0.0375. We do it in the calculator. Sorry, drop something. Do it in the calculator. Let's see. ln of 2 divided by 0.0375, and you get 18.48. So time is 18.48, rounded to the nearest tenth of a year, 18.5 years. So at that interest rate, 3.75%, it would take 18.5 years to double your money if compounded continuously. All right, last one. Researchers at a local area found that the population of rabbits had an initial population of 20, and it grew continuously at the rate of 5% per month. So the initial is 20 rabbits at a rate of 5%. So your formula will be, let's call it R of t, the number of rabbits, equals 20 e to the 0.05 t. And then over here you got 30 fox initially, and they grow at a rate of 30%, so it starts a little higher. So let's call it f of t, the number of foxes over time, 30 e to the 0.03 t. And it says find to the nearest tenth of a month how long it will take for the populations to be equal. So really the easiest way to do this is to just graph both of them. So let's do that. Let's graph both and see where their point of intersection is. So we get y equals 20 e raised to the 0.05x, and then we get 30 e raised to the 0.03x. I'm going to see what happens here. Okay, and where will they intersect? Right there. So when time is 20.27, they'll both have 55.11, which is kind of weird because you can't have that many rabbits, but let's say right here, 20.273. 20.27. So find to the nearest number of months. So you get 20.27. So you get 20.3 months. Okay, so go ahead and try out the homework and submit it by tomorrow.